Let us discuss some problems in electromagnetic induction. A small piece of metal, metal wire is dragged across the gap of gap between the pole piece of a magnet in 0.5 seconds. The magnetic flux between the pole pieces is 8 into 10 power minus 4 Weber. Estimate the induced EMF in the wire. Now, what are the parameters given here? Phi B, which is the flux, magnetic flux. And here P. So what is asked? E is asked. So what is the formula to be used? Induced EMF is equal to minus d phi or delta phi divided by dt or delta t. Okay. But let us consider the modulus means that is minus, you can put. So let me consider only the magnitude. Okay. So let us apply the formula. So given, what are given here? Phi b, the change is given. How much? 8 into 10 power minus 4 Weber. Take down. And what is the delta t, the time taken? That is 0.5 second. So to find what? To find E induced EMF. So the equation is this one. So let us apply E solution is equal to phi delta phi divided by delta t. So 8 into 10 power minus 4 Weber divided by 0.5. So second. So 8 into 10 power minus 4. 0.5 is 1 by 2. So 16 into 10 power minus 4. Right? So it means that is 1.6 into 10 power minus 3 volt. And this can be called 1.6 millivolt also. This is the answer. Okay. So on what concept, what basis of this concept, this question has been asked? Only d phi by t. Yes. Okay. Right. Next one. A jet plane is traveling westward at a speed of 1800 meter per hour. Sorry, kilometer per hour. 1800 kilometers per hour. What is the potential difference? What is the potential difference developed between the ends of its wings? So this is the aircraft. So this is moving at a speed of what? 1800 kilometer per hour. Now the potential difference between these two wings, across the two wings, is equal to, and the wing is of length 25 meter. Its earth magnetic field at the location has a magnitude of 5.0 into 10 power minus 4 Tesla, and the dip angle is 30 degree. So let us list the given parameters. What are the parameters given here? Take down. Given. What is given? B is given, right? And it is the vertical component, is it not? Yes, magnetic and developed the location has, okay, the dip angle, okay. So BV, and what is asked, what is the potential difference between them? Okay, right. So here, now listen, we have got the vertical component, So BV is equal to, BV is equal to B sine delta. This is the dip angle. So note down this point. And now we are talking about the potential, means EV. E at that point, okay, and inclined plane is equal to, it is given by B into LV, that is BV into L, and at that particular velocity. So this is another equation or formula. Now we had to consider the speed first. Okay, take down. What is the parameter given? B. How much? 5.0 into 10 power minus 4 Tesla. And then they are given the delta, the inclined angle also, dip angle. So this is represented by delta. So the delta is 30 degree. Okay. And the length of the wing is given. How much? The 25 meter. Then what is the velocity? The velocity at the 1800 kilometer per hour. So it should be converted into meter per second because these are all meter. So 1800 into 5 by 18. You know that factor? Do you know or not? Don't know. See, 1000 meter is equal to 1 kilometer divided by 3600 second. That is equal to 1 hour, right? So 0, 0 cancel, and this is 5 times, and this is 18 times. So 5 by 18. So we have to introduce this 5 by 18 factor so that you can convert this into meter per second. So 100. So 500 meter per second. So in 1 second, 500 meter is traveling. So this is the V, right? Now let us proceed with the, so we have got the two, I mean the vertical component, the wings of the jet plane will cut the uh, vertical component of the Earth's magnetic field, because the magnetic field at that location is B, but it has to cut the, it is flying like this, okay? It is flying like this. So it has to cut the vertical component of the magnetic field. So you have to calculate that one. So that is the BV. So you cannot directly use this B. Or you will follow, and that is why they are given this angle. And I think we already discussed about the sine of dip angle is equal to B by BV by B. We have studied under magnetism. Do you remember or not? So BV is equal to B sine delta, and we can use this equation to find out BV. And in the next, so this is equation 1. This is formula 1. And what is this angle? Delta dip angle that is given. B, that is the magnetic field on that spot, at that spot. And this is the vertical component of the magnetic field, that is BV. So in order to calculate this one, we have to multiply this B by sine of angle of dip, that is B sine of delta. Now we can make use of this BV, or you will follow now, and into, we know already this is length of the wing. That is something like a moving rod, right? Or you will follow. So you've got the moving rod, which is equivalent to the plane's, what is that? Wing length. Okay. So this is the surface area where it travels, or you will follow. In this way, the plane is going like this, right? And what about the vertical component of the magnetic field? It goes like this. Is it not? I hope now you should be able to understand why I have calculated dV, right? So this BV, and it has to cut, and thereby you are able to get the induced what? EMF across the wings. Are you able to follow? So that we are calculating. Take down. So let us apply the first equation. B vertical component is equal to B sine delta. And what is B given? How much? 5.0 into 10 power minus 4. Sine of 30. What is sine of 30? 1 by 2. Therefore, 5.0 into 10 power minus 4 into 1 by 2. So that is 2.5 into 10 power minus 4 Tesla. So this is the value, vertical component of the Earth's magnetic field. What is BV? Vertical component of the Earth's magnetic field. So that we have calculated, and that field is going to be utilized in inducing EMF. Okay. So what is the formula for inducing EMF? Induced EMF is equal to, IN means induced EMF, is equal to, what is that? B V into L, and this is V velocity. Okay, BLV. Now let us apply this. E induced is equal to, what is BB value here? 2.5 into 10 power minus 4 Tesla. What is the length? The length is how much? 25 meter into, what is the speed? 500. Okay, so get me the value. 3125 into 10 cube, 10 power minus 3. this much old. Okay, it means 3.125 volt is induced across the wing. So this is the flight. It has got the wing like this. Now the magnetic field is moving in this direction. Are able to follow? So it goes across this, and this acts as a rod. Okay, this is like our PQ. So when it crosses and across this, what happens? The magnetic, I mean the electric field is induced between these two fields. Are able to follow this? Yes. Hence the way. How much we have calculated? 3.125 volt. Okay. So this is a very interesting sum, and you should be able to think and apply the concept here. So let me take one more sum. With that, we will complete it. So we'll continue the next class later. Then last question for this section. Take down a circular copper disc of 10 centimeter radius rotates at 20 pi radian per second about an axis through its center, perpendicular to the disk. A uniform magnetic field of 0.2 Tesla acts perpendicular to the disk. Calculate the potential difference. Calculate the potential difference, that is the induced EMF here, developed between the axis of the disk and the rim. Now, a circular copper disc, okay, of 10 centimeter radius. So this is 10 centimeter radius. You should be able to visualize always any physics question. It is rotating about its axis. So this is the center axis. Okay. Now the uniform magnetic field acts perpendicular to the disk. How they are perpendicularly traveling like this. Okay. This is the direction of the magnetic field. And this is the rotating wheel. So it means what? The radius is moving like this. Is it not? Because it is rotating. Okay. And it is rotating at what speed? 20 pi radian per second. Okay. 20 pi radian per second. Now we have, you know very well, a rotating disk, and it is crossing the magnetic field like this perpendicularly. Then definitely there will be magnetic induction, because we have seen how the magnetic field, I mean induction can happen, induced EMF can happen, how? In how many ways? By changing the magnetic flux, by changing the area, by changing the theta, that is orientation. Now, what we are seeing, we are discussing about the motion EMF. Are you able to follow? Thereby, you are changing the area. In the case of the previous one, I was discussing in the what do you call the moving rod, where I was explaining about the PQ, how it is changing, right? And thereby the area is changed. Got it? In this case, the PQ is changing, how fast it is brought, how fast it is moving. Based on this area is changing. So, in the similar fashion, we discuss in the aircraft problem also the same concept. See that the wings are moving in this way. Okay. So it is crossing the magnetic field. So there arises the potential between these two wings. Okay. So in a similar way, now it is a rotating copper. Okay. Copper plate. It is rotating like this. So this rotating, now let me consider this as the radius, and this is the axis of rotation. It rotates like this. So when it rotates like it sweeps like, okay, in this way, and its speed is given here. So instead of rotating from one position to another position, here it is angularly happening. So what about the velocity here? It is angular velocity. Audible follow? In that case, we consider the linear velocity simply v. Here, what we are supposed to consider? The angular velocity omega. I hope now it is very clear, right? So this is the problem. I explained the situation. Now let us move. What is the first question? The potential, that is induced EMF, developed between the axis of the disk. So this is the axis of the disk and the rotating rim. Which is the rim? This is the rim, the edge. Are you able to follow? So what is happening? How the EMF is induced? And this is induced across the radius at the center and at the rim, the edge, the circumference. Do you understand this? Right. Now, second question, what is the induced current? What is the induced current? So they are talking about the current, induced current, IN. You can put like this. What is the induced current in the circuit whose terminals are connected between the center disk, the center part of the disk, and the point of ring? This is the ring. So they have connected a wire like this, and we are going to study the current passing through this. Are you able to follow? This is the induced. And here we are going to find out the potential across this. So EIN and IIN should be formed. Are you able to follow now? Okay. So what is IIN? IIN is the induced current between what? Between the, take down. IIN is the induced current in the circuit whose terminals are connected between center of the disk. Let me say this is O, center of the disk. And the edge, let me put P. And a point P in the rim. Rim means the edge of the wheel. The resistance of the circuit is 2 ohms. Okay. Now let us calculate. So what are the given parameters? Given. What are given? Can you tell me? Circular copper disc of 10 centimeter radius. Put R is equal to 10 centimeter. Immediately put 10 into 10 power minus 2 meter. Then rotates at the speed of then omega. It is angular velocity, right? So omega is equal to 20 pi. So 20 pi radian per second. Okay, done. And what is the magnetic field given here? 0.2. So B is equal to 0.2 Tesla. That is also given. Okay, right? Now this B, that is the EIN, induced EMF beta. Induced EN is equal to induced EMF is equal to, that is B omega. This omega is nothing but, this is obtained from, we know omega is equal to what? Linear velocity. Is that not? What is omega? Linear velocity. What is the relationship between V and the linear, sorry, omega is angular velocity. Omega is angular velocity, and V is linear velocity. So what is V? R omega. Do you understand this? So we have to put R omega. Okay. So R omega, you have got already R here. So therefore, the equation becomes omega R squared in divided by 2. So take down this formula. So you can substitute straight away for the first question. That is, what is us? E induced is equal to B omega R squared divided by 2. Can you substitute? 0.2 into, what is omega? 25. Okay. So 25 into, and R squared. So 10 into 10 power minus 2 whole square. Give me the value. So 0.2, 20 into 3.14 into 10 squared, that is, and this on 10 power minus 4 whole divided by 2. What is the answer? No. No, no, no. What about this 3.14? So very, very simple calculation. 6.28 6.28 into 10 power minus 2 volt is equal to induced EMF. Okay, theta. So this is the first answer. Second one. Now they are given, they asked the induced current. We can apply the Ohm's law. What is that? V is equal to IR. So EIN is equal to IIN into R. Okay. So it means IIN induced current is equal to how much? E induced divided by resistance. Okay. So this formula can be adopted. So 6.28 into 10 power minus 2 divided by, what is the resistance they are given? 2 ohm. R is given as 2 ohm. So 3.14 into 10 power minus 2. How volt? Ampere. Okay. So this is the second answer. Okay. So now listen to me. All these problems are based on what? Motional EM. Okay.